One second, sir.
So I can see Siddharth, you are coming for the first class, right? Unmute yourself before saying something.
Yes, sir. Yes, sir.
Which school you belong to?
SSM.
Okay. In SSM school, up to where they have finished? Which chapter?
First chapter, second chapter they have started.
Second they have started. Deepa Jyoti, what about your class? Deepa Jyoti, if you are hearing me. Manoranjan? Yes, Deepa Jyoti. What is happening at school? Which chapter? You are muted, Deepa Jyoti.
Second chapter.
Is it happening or is it finished?
Finished, I guess. Not sure.
Not sure what is happening. That is very bad. Manoranjan, what is your knowledge say about your school?
Sir, almost half of the lesson they completed.
Did they start capacitors?
No, sir.
Oh, they are much behind where we are, right? Fine, good for you. If you are ahead of school, then school should look easy to you. I believe so. Sriniketan, where they are?
3 chapters completed.
Fourth one is going on or not started? Tomorrow school is reopening. Oh, school is not reopened. Why? Only the school not to reopen by up to now is Sriniketan only. What about Velamal? Where they are? Fifth chapter. Tomorrow they are starting the school. School is closed still. Tomorrow 6th. 5th. Okay. What is happening at your school before the school closed?
3 chapters completed, 4th chapter is happening. Half chapter.
Fourth half they finished.
4th completed.
For your class, fourth completed. Nedugundram. For you people, it is fourth going on. Okay. Chaitanya, something else will be happening.
No,
Then?
they are doing with current electricity Ohm's law.
Oh, so they are in third only. What about this crescent? Second chapter finished. They are behind us. Aditya, SRM? 3 finished and fourth half. Then that is 3. That's 2.5, man. How 3.5? In third chapter they are in half. So current not finished yet. Am I right? Okay. I think every school I covered. Anybody is remaining. LW, what is happening? Kirti? Until third chapter. Until current, if I am right, Kirti? Okay. Pratap, what about your school?
Sir, in my school, we have come up to limitations of Ohm's law in the third chapter.
Okay. So which school is ahead of me? Only Velamal is ahead of me. No other school is ahead of me. Strange. Okay. So, as I was saying, Kavin, can you on your camera? Is it your first class, Kavin?
Yes, sir.
Please on your camera. In this class, you should not be with camera off. That is the condition.
After 2 minutes.
Don't take 2 minutes, make it fast. Right. So, Krishna Raghavan, what is happening at your school, man?
Yeah, they completed electrostatics. So, single chapter, no, sir.
Yeah.
In that, they have completed up to electrostatic potential. And they have completed electrostatic potential due to point charge.
Okay, I got your point. So, they are behind us. Kavin, which school you belong to, man? If you are hearing me.
Yes, sir. Sri Krish International, sir.
Oh, Shri Krish, what is happening at your school?
So they have completed 3 chapters, first 3 chapters.
Fourth not started?
No, sir.
Okay. When will you start your video, by the way?
Yes, sir. I'm having trouble with Zoom, sir. Just now I got out loud and.
Make it fast. Okay?
Yes, sir.
If you are not on your video for 5 minutes, I have to put you in waiting room. That's the condition here. Okay? Make it fast. Somehow on your video. Navina, if you are hearing me, on your video here.
So just a second, sir.
Still people have not come back to the form of the class because but schools are reopening and the exams will happen next week, right? Most schools will have exams in another 10 days. and so you should be ready for facing the examination. Meanwhile, today as per the plan, I am going to start the chapter number 4. As I said, chapter 4 is kind of lengthy chapter, but we will try to complete a bulk of it today. That's my plan. Let me see how much I am able to do. Almost 1/3 will be complete, whatever happens. My plan is to complete till half of this chapter, but for sure I will complete 1/3 in today's class. Okay? Today's class is going to be very, very, very important. Reason being, we are in the new chapter, and this chapter is something which you may start liking if you have attentiveness in the class. 7:25 one time. Somebody is coming behind you. Right. So, all of you please give the heading as moving charge and magnetism. Moving charge and magnetism. So, if you see in physics, the first 2 chapters were under the category of electrostatics, where we learned about charge at rest. Charge was at rest, it was not moving, and we talked about its properties, electric field, electric potential, isn't it? And different conditions, dipole, how the electric field is produced, torque acting on it, work done, all these things. But whatever was happening in that chapter, the charge was at rest. Chapter 1 and chapter 2, charge was at rest. In chapter 3, charge started to move. It became current. The moment the charge is moving, it becomes current. If it is a positive charge, the current direction is same as the flow of the charge. If it is a negative charge, the current flows in the opposite direction to the flow of charge. Electronic current and conventional current, we have learned about it. The moment charge to starts move and there is current produced, the current creates magnetic field around it. You have learnt about this chapter in 10th standard also. In 10th you had a chapter called as electricity, followed by magnetic effects of electric current. You remember this? Where you learned how current can produce magnetic field around it. Who found it first? Hans Christian Ørsted. Very good. Hans Christian Ørsted. Ørsted was the first person to find that there is some magnetic field produced whenever there is a motion of current. The current is flowing through a wire, there is a magnetic field produced around it. Now, Mr. Hans Christian Ørsted already told that if you have current passing through a conductor, you will have magnetic field around it. So, if you remember your 10th standard, there you learnt, first you learned the properties of the magnetic field produced by a bar magnet. Then you learnt what is the magnetic field due to a straight current carrying conductor. You learned it is concentric circles. Experiment you did, keeping a board, throwing some iron filings, tapping the board, concentric circles are getting formed. Then you learnt what is the magnetic field produced by circular current carrying conductor. A bigger board, a circular wire passing through it, iron filings spread, tapping the board, once again you got some pattern. Then you found what is the magnetic field produced by a solenoid, which is formed by many circular current carrying loops. And then you got that the magnetic field of solenoid is resembling the bar magnet, right? Then you learnt something about force on a current carrying conductor kept in a magnetic field. F is, formula you not learned, just learn the force. And then it was omitted. You had to learn about electromagnetic induction, which was not there in syllabus for most of you. So, whatever you have learned in your 10th standard, the same thing is going to repeat in 12th standard also, in a more detailed way, in a more understanding way, in mathematical way. Like now you know that if I have a straight current carrying conductor, it will have magnetic field around it. But how much magnetic field? You don't know. Today you will learn that. You know that circular current carrying conductor, you will have a magnetic field around it. How much magnetic field? You don't know. Today you will know that. You know that solenoid has a magnetic field inside it. But how much magnetic field you don't know. Today you will learn about it. So this chapter, we are going to quantify what you studied in 10th standard. In 10th, they taught you that current carrying conductor will produce magnetic field. But today we will learn how much magnetic field, the quantity of magnetic field produced by the current carrying conductor. Shall we start the chapter? Right. This chapter starts with the first concept of Biot-Savart law. Give the heading as Biot-Savart's law. Biot-Savart law. So, Oersted already found that current carrying conductor has a magnetic field around it. Biot-Savart wrote a mathematical expression of what is the magnetic field produced by a current element, right in the bracket below this, magnetic field due to current element. Now, first thing that comes to your mind, should come to your mind, is what is the meaning of the word current element? What is this current element? Okay, let me explain this to you. I'll give time for writing. Now, pay attention, put your pens down. So, suppose I am having a wire, a random wire, and if I take a small portion of it, if I am having a long wire and from that long wire I am cutting out a small portion of wire, don't you think that the small portion of wire will also carry the same current as carried by the whole wire? Or will it be less current, isn't it? It will be same current. I hope you are getting my point. If 2 ampere current is flowing, do you think here only 0.1 ampere will flow? Not like that. 2 ampere flows entirely to the wire. So, current element is a small part of the wire which carries the same current as carried by the whole wire. Is it clear to you? I will repeat. Current element is the small portion of the wire which carries exactly the same current as carried by the whole wire. So, we denote this current element by DL. Since it is a small part of the wire, we are taking it as DL. Our intention, I will give time for writing, I said. Our intention is to find what is the value of magnetic field, somewhere random point. I am taking like this, r distance away from it, and what is the magnetic field at this point. That is what Biot-Savart did. What they did? They found the magnetic field due to a current element, randomly anywhere, somewhere here, anywhere. So, if you have a wire which is carrying a current, then if you go r distance away from it, what is the value of magnetic field that was found by whom? It was found by using Biot-Savart's law. Now, the angle which this distance makes with dl, let me take it as theta. So, what these people did, Biot-Savart, what they did, series of experiment they did. In experiment, they changed the dl length. They took 1 millimeter dl, 2 millimeter dl, 5 millimeter dl. Are you getting? They changed the dl's length. They changed the theta. They changed the current going in the wire. And by changing all these things, they tried to define or find what is the value of magnetic field they got at that point. So, by the experiment, since we are taking a small element dl, I will write small magnetic field dB. They found experimentally that dB is proportional to I, that is, more the current flowing through the current element, more is the magnetic field. Less current, less magnetic field. Second, they found this magnetic field is proportional to dl. They saw that if they are taking a greater part of the current element, we have a stronger electric field. If we have a smaller part of current element, we have a lesser electric field, lesser magnetic field. Then they found this magnetic field is proportional to sin theta. Theta is the angle made by the distance with the current element dl. And they found that this magnetic field is inversely proportional to square of distance. When they combined all this thing, they wrote dB is proportional to I dl sin theta by r square. To remove proportionality, they added a constant, and that constant they are writing it as k. dB is equal to some k times of I dl sin theta by r square. This k was found to be equal to mu naught by 4 pi. Like how you have constant in the case of electrostatics as 1 by 4 pi epsilon naught, here they found mu naught by 4 pi into I dl sin theta by r square. You may ask me, what is the meaning of the word mu naught? You know it from the previous chapter? No, you don't know. Mu naught is called as permeability of free space. It is called as permeability of free space. And its value is how much? Its value is 4 pi into 10 to the power minus 7. Like how we had the value of epsilon naught as 8.85 10 to the power minus 12. Here we have mu naught, which means permeability of free space, and its value is 4 pi into 10 to the power minus 7. Some of you may say that, sir, directly I can cut 4 pi, I can write 10 to the power minus 7. No, you can't do that. But this 4 pi can be very helpful sometimes to you. I'll prove it today. So if you want, we can cancel 4 pi also and directly write here 10 to the power minus 7. Correct only. But I prefer to keep this mu naught by 4 pi because it helps in many places. Are you getting? This is the expression for Biot-Savart law. So as per Biot-Savart law, small magnetic field dB produced by a current element dl is given by mu naught by 4 pi I dl sin theta by r square, where I is the current flowing through the current element, dl is the length of current element, theta is the angle made between the distance with the current element, r is the distance of the point where you find the magnetic field from the current element. Is it clear to you? Whatever I am writing is the scalar form of magnetic field. If I want to write the same expression in vector form, then what I will do? I can write. So I am writing it here. If I am having dB vector, then it becomes mu naught by 4 pi. Current is a scalar quantity, everybody knows this. I taught in the previous chapter itself to you. So it cannot be I vector, because we know that A vector cross B vector is equal to A B sin theta n cap. So I cannot write I dl sin theta, so I vector cross dl vector. I cannot write that because I is not a scale vector quantity. So I will write mu naught by 4 pi I into dl vector cross r vector. If I do that, it will become dl into r into sin theta. One r will come. That r should make it r square. So in bottom I will write r cube to r cap will come. Is it clear to you? So in the board examination, this question has come. What is Biot-Savart law? MCQ. In the option, if this is there, tick this. So dB is inversely proportional to r cube if Biot-Savart law is mentioned in vector form. dB is inversely proportional to r square if Biot-Savart law is mentioned in scalar form. So what is this? Biot-Savart law in which form? Vector form. So Biot-Savart law in vector form is mu naught by 4 pi I dl vector cross r vector by r cube into r cap. If it is clear, copy it first. Yes, ask Mr. Chandra what you are asking.
Speaking about current element, are you referring to the size of the wire or the material of the wire?
You are talking about is dl.
No sir, the current element.
Huh. Current element is size, that is wire is there, cut some part of the wire. This wire is called as current element.
So it's not material. Not about material.
It's not about material. Here we are not talking about material. Material we are talking, you know how? By mu naught. Because different materials will give different permissions for the magnetic field to go. So mu naught indicates about the material, not the dl. dl is all about the wire, not the type of wire. Okay? Length of wire it is. Copy it fast. Sarvanan, I don't want you to off your camera, man. Don't make me to repeat all these things on your camera, this thing, that thing. Please make sure your camera is always on.
Sir,
Yes, man.
this K, is it dependent on medium or?
Obviously, K depends upon the medium. That's why mu naught came, no? Permeability of free space. If medium is changing, K will change.
Okay.
Sir, what is permeability, sir?
Permeability is the permission given by the medium to create the magnetic field. Like how permittivity is the permission given by the medium for charge to interact. Here permeability is the permission given by the medium for the magnetic field to reach that point R.
Okay, sir.
Excuse me, sir.
Yes, please.
Are there any specific units for Biot?
Yes, obviously it will be there. I not wrote there, but you can write no, because the magnetic field is Tesla, distance is meter square, current is ampere, dl is in meters. You can write it, isn't it?
Yes, sir.
It has unit.
You are wondering U naught value is 4 pi into 10 to the power minus 7, sir.
Yes, mu naught value is 4.10 minus 7. Is there anyone known as Gautam here? Anybody's parent name is Gautam? Because one Gautam student is mentioned here. Nobody is Gautam, right? When he used to come? Okay, Gautam, that Gautam, huh? Okay. I forgot him. I have seen him very rarely.
Sir, could you explain this Biot's Savart's law in vector form once again, sir?
I'll explain. Once again, I'm taking attendance now. I'll explain it. Mrityunjay is absent, right? Nikhil is absent. Yashwant Kumar is absent. Yashwant is there, right? Yeah. So, Kalai I think you are asking to explain this Biot-Savart law in vector form once again, right?
Yes, sir.
Yes. So, what I have done here we have I dl sin theta, right? I hope you know that A vector cross B vector is equal to magnitude of A into magnitude of B into sin theta into n cap. You know this?
Yes, sir.
Okay. So, here I want to write in vector form. I cannot write I vector cross dl vector because I is a scalar quantity, right, Kalai?
Yes, sir.
So, what I am doing? I am writing dl vector cross r vector and then I know that if I write dl vector cross r vector, it will become dl into r into sine theta into r cap. Saranan, I mute yourself, man. So dl into r into sine theta. So if I write, if I get that, this r will cancel this r cube to become r square, right?
Yes, sir.
That's why I wrote in this terms.
Okay, sir. Okay, sir. Understood, sir.
I hope you got my point.
Yes, sir. Thank you, sir.
Can I proceed further? So now you came to know that if I am having a current element, then r distance away from it, the value of magnetic field, small magnetic field dB will become equal to mu naught by 4 pi into I dl sine theta by r square. Let me not write it because some of them may not be able to see it. So dB will become equal to mu naught by 4 pi I dl sine theta by r square. By using this law only, now we are going to derive what is the magnetic field due to various conditions, right? So this topic is not there in syllabus, but I am going to teach you. Reason is, this topic is not there, but its application is there in the later part of this chapter. So let me teach you that. Give the heading as magnetic field due to straight current carrying conductor. Straight current carrying conductor. So, as I said, this topic is only there in competitive topic classes. It is not there in regular class. They have removed it last 2 years back. So, if you have a straight current carrying conductor like this, taking current I, then if I go from this center, assuming the wire is long, very long, and if I am going to find what is the magnetic field here, the value of magnetic field here, I am directly writing the expression of it. Derivation I am not doing, it is not required, but I am writing the expression for you. Let me write the expression, please pay attention. If I join the top of the wire and the bottom of the wire, okay, assuming that this angle is theta and this angle is phi, okay, or theta and theta 2, whatever you want to take. So if it is theta and phi, so the magnetic field here will be mu naught I by 4 pi r. R is this, in bracket sine theta plus sine phi, or I should write sine theta 1 plus sine theta 2. This is the expression for magnetic field due to a straight current carrying conductor r distance away from its center. Is it clear to you? So if you have a straight wire of some finite length, okay, and if you are going some r distance away from it, not exactly from its center, it can be from anywhere, and it is subtending an angle of theta 1 in the topmost point and theta 2 at the bottommost point, then magnetic field here will become equal to mu naught I by 4 pi r into sine theta 1 plus sine theta 2. This is the expression. Okay. Now there are multiple possibilities after this. If wire is infinitely long, infinitely long means very, very, very long, okay, and let this point be P, and P is at the center, P is at its center, then what is going to happen? Don't you think so that theta 1 will become equal to theta 2 will tend to 90 degree? The more it becomes long, angle will increase. It will never become 90 degree. It will tend to 90 degree, right? It can become 89.9 also, but it will never become 90 degree. So I am writing theta 1 and theta 2 will tend to 90 degree. If theta is tending to 90 degree, where will sine theta tend? Sine theta 1 or sine theta 2 will tend to what? 1, because sine 90 is 1. So what will happen to this expression? B will become mu naught I by 4, actually directly if I write 2 pi r, isn't it? Because 4 pi r into 1 plus 1 will become 2, 2 will make it 2 pi r. This is used in many places in 12th standard, in school itself. They will write somewhere magnetic field due to a straight current carrying conductor is mu naught I by 2 pi r. How it comes? From here only it comes. Are you getting? And this is not at all used in school syllabus. You will never use it. But if you write any NEET or JEE examination, definitely you will use it. This expression is not at all there in school syllabus. But from this expression only, this expression has come, which is used in many places in school exam, CBSE board itself. So remember, if you have a straight wire, very long wire, then magnetic field r distance away from it is mu naught I by 2 pi r. Is it clear to you? Please ask me, Kirti, be a little louder. I am not able to hear you clearly. Yes.
What's the meaning of 10 to
10 to means, if you see the wire is small, okay, the angle is a small angle, right? If the wire becomes bigger, the angle is increasing. Do you agree, Kirti? If the wire becomes further bigger, the angle is further increasing. So theta, from 0 it moving towards 90 degree, right? It is 0 initially, slowly it is going towards 90 degree. It will never become 90 degree, but it will go towards 90 degree. That is why I wrote theta is tending to 90 degree and sin theta will tend to 1, because sin 90 is 1, right? Again, one possibility which is not there in school syllabus, not required also, but I am telling you, that is, if they tell that the wire is infinitely long, but the point is r distance away from bottom or top, then what will happen? Theta 1 will become 90 degree and theta 2 will become 0 degree, isn't it? So in this case, I will have B as mu naught I by 4 pi r. Don't you agree with me? Because sin 0 is 0, sin 90 is 1. So there are 3 formulas of magnetic field for a straight current carrying conductor. If the wire has finite length, it is mu naught I by 4 pi r into sin theta 1 plus sin theta 2, not required for school exam. If you are not bothered about anything, that is no NEET, JEE, VIT, nothing I want, I just want school, then forget all these things. For you only this is required, which is for an infinitely long wire, r distance away from it, the magnetic field value is mu naught I by 2 pi r. So hereafter, whenever I am talking about a straight wire, I will tell magnetic field due to a straight wire will be mu naught I by 2 pi r. Are you getting how it came? It came from here. Is it clear? If yes, please copy fast. This is the magnetic field due to a straight current carrying conductor.
Excuse me, sir.
Tell me, Pratap.
Sir, you have written me 2 equal to 4 pi r.
Haan.
Could you please explain that?
Are you talking about this?
The right?
This one?
Yes, sir.
I said that if the wire is infinitely long and you go r distance away from its bottom,
Okay, sir.
then one angle became 0, right?
Yes, sir. Yes.
And only one angle is tending to 90 degree. So one will become sin 0, one will become sin 90. Sin 90 is 1, so it will become mu naught I by 4 pi r. Got it?
Okay, sir. Yes, sir.
Yeah. And again I am repeating, for school only this is required, okay? Don't worry about anything else. We will not use anything else anywhere. What we are going to use in school is only mu naught I by 2 pi r. If you are done writing, I will go to the next page. Shall I? Make it a little fast. Shall I proceed? If you remember, in your 10th standard, you studied that if you have a straight current carrying conductor, then magnetic field due to it is concentric circle, isn't it? So we came to know if I am having a straight wire, magnetic field is like this. But what is the value of magnetic field here? It is mu naught I by 2 pi r if it is very long wire. Otherwise, mu naught I by 2 pi r, 4 pi r into sin theta 1 plus sin theta 2. One more thing, again for only competitive examination. A question came, this question has come in the NEET examination. Question has come like, what is the magnetic field due to a straight current carrying conductor? And there was option in which this option was not there. Rather, the option was B is equal to mu naught I by 4 pi r into cos theta 1 plus cos theta 2. Is it possible? It is possible. If this is taken as theta 1 and this is taken as theta 2, isn't it? Don't you agree with me? Because if it happens like that, then this angle will become what? Theta 1 in terms of, let me take it as phi if I am writing. Yes, for your understanding. Yeah, now tell me, what will be theta 1? 90 minus phi 1. And what is sin 90 minus phi 1? Cos phi 1. Are you getting? This twist is very simple twist, but they will confuse. They will think I studied sin theta only, how cos theta came? Because they took different angle. Sin theta is only for this angle, okay? Not required for school students, don't confuse yourself much. Coming back. So what I was saying, if you have a circular current carrying conductor, this is the value of magnetic field. But why always you are thinking in 3 dimension? If I am assuming in 2 dimension, for example, this is board, this is the wire. If I ask you at point A, what is the direction of magnetic field? What you will say? Down, not the correct word. Into the plane is the correct word, isn't it? Because as per right hand thumb rule, try to remember from a 10th standard. If you hold a straight current carrying conductor in your right hand and thumb is pointing towards direction of current, then your 4 fingers will point towards direction of magnetic field. So the current is like this towards my right, my fingers are trying to go inside, isn't it? So into the plane. This side, it is trying to come out of the plane. So for point B, the magnetic field is out of the plane. Are you understanding my point? If you have a wire like this, at point A, what is the direction of magnetic field? How out here? Into only, no. My fingers are trying to go inside. And if I take at point B, obviously out. My fingers trying to come outside. Don't see by the board, you can write on a notebook and check. Obviously it will come. I hope you are understanding what I am trying to tell. Is there any problem in this? What, Mr. Aditya Raj? Any problem? Huh? Sure? Okay. So if yes, then give the heading as magnetic field due to circular current carrying conductor. They are in syllabus now. Circular current carrying conductor. The case number 1, the first case is at its center. At its center. So now what I am going to do? I am going to draw a circular current carrying conductor like this, and I am interested in finding what is the magnetic field at its center when the current carried is I in this. Direction is into the plane, but what is the magnitude? Sit here, sit here. Come here, man. So what we are going to do, we are going to find what is the magnetic field due to circular current carrying conductor at its center. As Niranjan told, if it is going like this, it is into the plane only. Yes, you are right, man. The magnetic field will be like this, going inside it. But the question is, what is the value of magnetic field? How do you find that? Please pay attention, I will give time for writing. We will use Biot Savart Law now. So what I am going to do, I am going to take a current element, small current element dl, and for this small current element dl, I will try to find what is the magnetic field dB. And I know what is the value of magnetic field. dB is equal to, what is the formula? Mu naught by 4 pi I dl sin theta by r square, isn't it? Small magnetic field we know. So small magnetic field dB here will be I mu naught by 4 pi I dl sin theta by r square, right? Now, what is theta here? This current element and this radius, what is the angle they are making? 90 degree, right? So since theta is 90 degree, can I write dB is equal to mu naught by 4 pi into I dl by r square. Can I say like this? And to find the complete magnetic field, I have only found for the small dl. I will integrate it. So integration of dB will become integration of mu naught by 4 pi into I dl by r square. When I do this, Shrish, if you are hearing me, Shrish, are you able to hear me?
Yes, sir.
Man, what time you are joining? 8 o'clock. Today it is 12th class, man.
Oh, sorry, sir.
Yeah, it was, the practice class will not be held here, okay? Okay.
Okay.
So integral of dB is equal to integral of mu naught by 4 pi I dl by r square. So it will be obviously 0 to b and this will be 0 to L. So integration of dB will become b, will become equal to mu naught by 4 pi into integration of I will come outside. Okay, tell me one thing, I by r square will come outside. What is the integration of dl? If I integrate the whole length, what will it will become? 2 pi r, isn't it? Because if I take the full circle of the circumference of the circle, it will become 2 pi r. So what I am going to get b as? I am going to get mu naught by 4 pi into I by r square multiplied by 2 pi r. This r will cancel this r. This 2 pi will cancel this 2 times. What I am going to get b as? Mu naught I by 2r. Magnetic field due to straight current carrying conductor is mu naught I by 2 pi r. Magnetic field due to a circular current carrying conductor is mu naught I by 2r. This will confuse you a lot, because in your brain you will think circle it must be 2 pi and straight it must not be half pi. Ulta is there here. For straight wire we have mu naught I by 2 pi r. For circular wire there is no pi, we have only mu naught I by 2r. So we came to know that if you have a circular current carrying conductor, at its center the value of magnetic field is how much? Mu naught I by 2r. If it is clear to you, copy it fast before we go to the further concepts.
Sir,
Tell me, man.
how integration of dl became 2 pi r, sir?
DL is small portion of the circular loop, right?
Yes, sir.
What is the meaning of integration? The complete length, isn't it? So what is the complete length of the circle?
Okay, sir.
Circumference. What is that? 2 pi r, right?
2 pi r. Okay, sir.
That's why how it came. Got it? This is a simple derivation which is not going to come in the school examination. Okay? Since it is very simple, it is not going to come in the examination. What is going to come in the examination is what I am going to teach now. That is, we are going to find magnetic field due to circular current carrying conductor. What we wrote at its center now, right? Now we are going to find at its axial point. This thing, I don't know how many of you will understand now. I will try to keep my level, I mean, whatever I can do, best I will do for you. Please be concentrated. It is little confusing. If you understand, it is good for you. Okay? Please pay attention. So, up to now what I did, for a circle, I found in the center what is the value of magnetic field. Now, this circle, I am going to go from its axis some distance away and I am going to find what is the magnetic field there. It means, if I am having a circular loop like this, from its center, where I am going? I am going some distance away. Let me take, I am going r distance away. And here I am finding what is the value of magnetic field. Is it clear to you? So, how it is in 3D you are imagining? This is circle. Earlier I found in this circle center. But now I am finding in this circle, from center if you draw a line, at this point what is the magnetic field? For this circle, at this point what is the magnetic field? I hope you are understanding. Okay. So, once again what I am going to do? I am going to use Biot-Savart law. So, now suppose I am taking the current element in the top like this. This one is current element dl. Okay. So, whenever we find the magnetic field from a current element, from current element we are drawing a line and we wrote it as r earlier, I am writing it as s now. Right, in the Biot-Savart law, what we are doing? From current element we are drawing r distance away, right, to find the magnetic field. Here also from current element we are going r distance, instead of r I am writing s, because already I have used r for distance away. And since I have used r here, I am taking the radius of this circle as some a. Is it clear to you in 3D how it is? Radius of the circle, let me draw like this, say like this. Circle is there, its radius is a. Okay. From its top, I have joined a line like this. Are you feeling how the line is joined? This is S and this distance is R. From the center, this is R, this is A, the radius is A, and from the top, this line is S. Are you able to imagine this? I hope. I will even show a diagram to you if you want. So, now first tell me that where will the magnetic field be? Very difficult to draw on the board, because this is the current element. From current element I have drawn a line. So, we know that if the current is flowing like this, okay. So, okay, let me tell this here itself to you. Since we are getting the direction of magnetic field dB, it is dl vector cross r vector. Coming to 11th level of vectors. If I am writing I vector cross j vector, what is the answer? K vector, right? I cap cross k, j cap is k cap. It means what? If you have a cross product of two vectors, the resultant will lie in the axis perpendicular to the axis which contains these two axes, isn't it? So, the magnetic field will lie in the plane perpendicular to the plane which consists dl and r. Please try to understand this. dl and r are in this plane, right? So, here the magnetic field came into the plane, right? Is the current was going like this, assuming current is going like this. right? So into the plane is what? Perpendicular to this board, isn't it? I hope you get my point. So always dB vector will, where will it lie? It will lie perpendicular to the plane which consists dB and R. So here we have to go to which plane? The plane which is consisting DL and S, and my dB will lie perpendicular to that plane. Yes, obviously. And so it lies somewhere like this. I am drawing. It is not like this in this direction. It is somewhere inside. Okay, are you getting my point? If I draw in 3D, if I make you understand, this is the circle. In this circle, this was the S, and dB is lying somewhere here. Are you able to feel? So don't think it is lying in this direction and in the 2D. It is lying in the inside the plane of the board. So I am drawing something like that. Okay. Now please pay attention. You can understand that this line where I have drawn the dB is perpendicular to S, that's for sure, because obviously it will be perpendicular to the plane. If I draw a line here like this, okay, can I say that if this angle is theta, this angle will become 90 minus theta? And if it is 90 minus theta, this is 90, this will become theta? Little confusing, please understand this. I am just drawing from this line straight line. Okay? If this is theta, this will be this is perpendicular to this, 90 minus theta only. And if it is 90 minus theta and this is theta, this will be theta because this is 90 degree. dB, this will become dB cos theta, and this will become dB sin theta. Do you understand this? Little confusing, I don't disagree to it. But please visualize this, no other option you have. And I told this is important for exam also. Tell me, Sharan Ram.
Sir, sir, from that straight line where you have drawn one name called as dB, no, sir? That dB is going inside the plane.
Like this, like this it is going.
Sir,
Hmm.
sir, can you explain the idea concept again?
How I vector cross J vector?
Not that, sir.
Huh.
How did you use in this case?
I used dB vector is equal to mu naught by 4 pi into I into dl vector cross r vector by r cube, right? Biot Savart law. It means dB will lie in a plane perpendicular to the plane consisting dl and r. Because if I cross j is k, the resultant is lying in the plane perpendicular to the plane consisting I and j, right? So I said that dB will lie in the plane perpendicular to dl and r. That's why in the Biot Savart law, dl was here, r was here. So magnetic field came into the plane if the current was going like this. If the current was going downwards, and if I take here, it will be out of the plane. Even out of the plane or into the plane, both are perpendicular only, no? So here what is happening, this is dl, here dl is there, and here s is there. So I am drawing the dB perpendicular to this, okay? And with this dB, I have understood that it is perpendicular to this s, and now if I am taking this as theta, then this is perpendicular. So it will become 90 minus theta, and this is once again 90 degree. 90 minus theta, so it will become theta. Somehow understood something? Same way, if I take current element down, dl, and join below, and take this as theta, this where somewhere we will get dB. Here you will this will become automatically theta. This will become dB cos theta, and this side you will have dB sin theta. This topic, if you are dreaming something else, gone. This chapter itself gone. So please be in the class focused today. This is complicated topic. It can hurt you entire year if you are not understanding this. Please Please pay attention, be in the class. Yes, Niranjan, please.
The DV down here into the page, is it when current is flowing out here?
No, I have taken a different current element, no. This current element is only for this thing I have drawn dB. I have taken dB here, DL here now.
This one comes towards us, dot dB.
Yeah, it comes towards you. Yes, it comes towards you like this.
So cos theta will get cancelled.
Yes, that one I am going to tell next. Thank you. Now please pay attention. What is going to happen? See, I have just taken 2 points, top, bottom. For that, I have got dB cos theta, dB cos theta, dB sin theta, dB sin theta, right? Like that, there are so many points possible on the circle, so many current elements are possible, right? If I take current element here and current element here, then I will get dB cos theta, dB cos theta, dB sin theta, dB sin theta. Do you agree with me? Please understand what I am trying to say. For every current element which are diametrically opposite, you will have dB sin theta in the same direction, but dB cos theta in the opposite direction. So, all the dB cos thetas will cancel each other for the whole current element, whole wire, circular wire, and all the dB sin theta, dB sin theta, dB sin theta will get added up. Do you agree with me? I hope you are understanding this. Little complicated, but somehow try to understand. So, what I did on this circular current carrying loop, I took a point dl, point current element dl, and for that I found dB. I resolved it. I got dB sin theta in this direction and dB cos theta in this direction. When I took the bottom current element, I resolved it. I got dB sin theta in this direction and dB cos theta in the bottom direction. So, dB cos theta above and dB cos theta below are going to cancel each other, and dB sin theta will get added up. Like that, how many dB sin theta will come? Multiple based upon the whole wire. So, now what I am going to do? I am going to apply the Biot-Savart law. For that, let me start writing. Now, please pay attention. I will give time for writing. I am going to write a statement now. Okay. So, the net total magnetic field, can I say total magnetic field at the axial point, will become integral of dB sin theta. Do you agree with me? If I integrate all the dB sin theta, I'll get total amount of magnetic field, because one is not there. For whole circle it is there. So, I am going to integrate the complete dB sin theta. What is dB, by the way? dB by Biot-Savart law is mu naught by 4 pi into I dl sin theta. What is sin theta here? 90 degree obviously, theta, by r square. Here it is not r square, here it is s square. Do not confuse in this. Biot-Savart law is for this part, right? So, mu naught by 4 pi I dl sin theta. Why I am saying theta is 90 degree, you know? Because this is a dl tangent and this is the s. So, this tangent and this s is perpendicular 90 degree only, no? So, this theta is 90 degree. So, I can write sin 90 directly here, no problem. And obviously sin theta is going to come. This sin theta is different. This is different, do not confuse. dB only I am writing here. dB is mu naught by 4 pi I dl sin theta by r square, and this dB multiplied by sin theta. Now, further solving it, this will become mu naught by 4 pi, sin 90 will become 1. So, I by s square, and sin theta is there, and what will be the integral of dl? Same, 2 pi r naught will not come, a is there, radius, 2 pi a will come. So, I will get the value of magnetic field as mu naught by 4 pi into I by s square into 2 pi a into sin theta. What is sin theta? You see this triangle, what is sin theta? Tell me, what by what? A by s. Can I say like this? Okay, I can write. So, sin theta will become a by, what is s? Root over, or let me write it as s itself. Later I will change. S. Is it clear to you up to here? So, yeah, any problem?
Why is there an extra sin theta?
Because the dB sin theta is the magnetic field produced by one current element, right, Kirti? So, if we have so many current elements, I am going to integrate this total dB sin theta to get the net magnetic field. And dB formula is mu naught by 4 pi ideal sin theta by r square. So, that is separate, and then remaining sin theta remains. Are you getting my point? Don't confuse in both. I hope you are understanding. So, from here I can write magnetic field B is equal to mu naught by 4 pi into, or why 4 pi? 2 pi will cancel this 2 times, no? So, mu naught by 2, mu naught by 2, above what is remaining? I, A square is remaining, and down what is there? S cube is there. What is S? S is root over A square plus R square, the whole cube, right? So, can I write this expression as B is equal to mu naught I A square divided by 2 into A square plus R square power 3 by 2. Very important for this chapter. Magnetic field due to circular current carrying conductor at its axial point is given by the formula mu naught I A square by 2 into A square plus R square power 3 by 2, where A is the radius of the circle and R is the axial distance of the point from the center of the circle. There is no S in this expression. Understanding this? What is A? A is the circle's radius. What is R? Axial distance of this thing. One more thing, please, before you start writing, one thing. If from here I take R is equal to 0, what will happen? R is equal to 0 means this point becomes central point, isn't it? If R becomes 0, this point becomes center point. So, put R is equal to 0 here. This will become A square power 3 by 2, it will become A cube. A square will cancel this A cube, it will become, you get the same thing, no, like what you derived earlier, mu naught I by 2, pi will come, right? 2A will come. Mu naught I by 2A. The same thing we derived, no? Mu naught I by 2R. R, here we took R, here we are taking A. So, this derivation can even be done from here also. What, Ranjan? Confusion? If you have understood or not understood, copy it first. If you are understanding or not understanding, first copy it. Yes, Vigneshwaran. How angle between S and DB? See, because S is like this, and we know that S and D are in this plane. So, DB must be perpendicular to this plane. So, only I am saying S and DB is making an angle of 90. Because S and DL, whichever plane they are, DB should be in a plane perpendicular to it. That is what the rule says, cross product rule. Cross product rule says that magnetic field will lie in the direction perpendicular to the plane which consists DL and R. Here we are taking R as S. So, this DB is perpendicular to DL and S. Are you getting my point? Don't stress too much, write it now and remember how the derivation has been done. Yes, ask me, Manoranjan.
Sir, is the dB cos theta phased towards into the plane?
No, man. dB cos theta is phased like upwards, one is downwards. One will be, some dB cos theta may be acting towards you and some may acting away from you also. Are you feeling how it is? It is like spokes of the wheel, like this, like this, like this, like this, like this, everywhere it will be. And every 2 dB cos theta which are opposite to each other will cancel each other. Are you getting Manoranjan?
Okay.
I hope you are understanding.
Okay.
Yeah. Copy fast, then I will tell you how the questions are coming in board exam from here. Let me know if you are done.
Done, sir.
Here everybody is done. Can I proceed further? So you understand that if you have a straight current carrying conductor, I am assuming infinitely long straight current carrying conductor, then the magnetic field r distance away from it is mu naught I by 2 pi r. If you have a circular current carrying conductor and its center point, the magnetic field is mu naught I by 2 r. And if you have circular current carrying conductor at an axial point r distance away, and if you have A as the radius, then B is equal to mu naught I A square by 2 into A square plus R square power 3 by 2. Is it clear to you? This is going to be used in many places. So whatever I have taught you till now, I am going to tell you how in the board examination questions are coming from here. Which kind of questions have come in the past and how to solve those questions. Okay? We will start one by one. But before I start, I would like to say something to you. If a question comes like you have there is a wire taking current like this. Okay, this is the wire taking current I. And if I ask you, what is the magnetic field at this point? How will you find it? Arc is there, yeah.
1/6 of the, if it was an actual circle, and then you take
Good, correct. It is fine. I can,
It would be a fraction of the circle.
Yeah, how much it will be? 1/6, right?
1/6.
Yes,
Yes.
correct, you are correct. We can formulate it. How we can formulate it? For 2 pi radians, what is the magnetic field at center? Mu naught I by 2r. So for unit radian, what will be the magnetic field? It will be mu naught I by 2r divided by 2 pi. And for some x radian, I am taking theta radian. For some theta radian, what will be magnetic field? It will be mu naught I by 4 pi r times theta. Remember this, very, very, very important. So, as he said, here theta is how much? Pi by 3, isn't it? So, the answer will be mu naught I by 4 pi r into pi by 3. You will get the answer. Because what is the value of theta here? 60 degree means pi by 3, right? I hope you are getting my point. So, if I am asking you, what is the magnetic field in this point? What is current? What is the answer? Mu naught I by 4r. Why pi will come? 4r will come. Because half of this. Or we can use this formula also. Mu naught I by 4 pi r into, what is theta here? Pi by 2. Pi will cancel this, isn't it? Pi by 2, pi is there. Why pi by 2? 180 degree. So pi. So it will become mu naught I by 4r. I hope you are getting my point. Now let me tell how the questions are coming in the board exam. Shall I show some questions to you? Okay. Are you writing something? You want to write something? Take 2 minutes. This is important. You can write this. You can write this, it is important.
So for this arc, it will be 1/6 of the value of the axial point.
Of the central point, no? For which one you are saying? For this one only, no?
The arc, yes, sir.
Yeah, 1/6 of the value for the central point.
Okay, sir.
If you allow me, I will proceed. And one very famous question I will give you, which has come in the past examinations, board year. Shall I? Go to the next page. Okay. Very famous question that has come in the board examination. Take it out. All of you, please start doing it. You have to find what is the magnetic field here. Okay. This is given as theta, and this is given as L, this is given as L, and this is also given as L, and the current is like this. Clear? The question is clear? How the wire is going, I hope you are understanding. Wire has a length of 3L totally, if you see from here to the last. I am not considering this length, L and here L and here L. Totally it is 3L from here to here. I am talking about the radius is 3L. Okay. Now tell me what is the value of magnetic field at that point. Try, give a try. I will help you otherwise. Interesting question. mu naught I by 12 pi r into, some mistake may be there, think. Yeah. Some mistake.
12r into theta by
Mistake.
11 mu naught I theta by 24 pi r.
Tell again.
11 mu naught I theta by 24 pi r.
Some mistake. Shall I help you? Yeah.
Is it 3 mu naught I by 4 pi?
No. Shall I help now? Anybody from online? Anybody has any answer? Good question. Okay, listen to me. I'll help you if you check whether what you are doing is right or not. First of all, understand that this portion and this portion are not going to contribute to the magnetic field at this point. I hope you are understanding why. Because if you have a straight wire like this, and if I ask you what is the magnetic field here, the answer is 0. It will not contribute to magnetic field. The magnetic field will be produced only on this side or on this side. On the wire, on the axis, there is no magnetic field produced. So this wire, here's the magnetic field will be there, here's the magnetic field will be there, but on this line magnetic field will not be there. Are you getting my point? Same way for this also, same way for this also. So magnetic field is going to be only by this part. I am writing it as AB, the part CD and the part EF. Do you agree with me? Magnetic field is only by AB, CD and EF. That too, directions will not be same of the magnetic field. Why? Because if you see properly, you will realize here it is going in this direction, so magnetic field will be inwards. So magnetic field produced by AB will be in which direction? Into the plane. Do you agree? See here, AB, so thumb is going inside. For CD, it will be out of the plane. So magnetic field produced by CD will be which direction? Out of the plane. And once again by EF, it will be into the plane. First, do you understand this, what I have written on the board now? Magnetic field produced by AB will have inward direction, CD will have outward direction and EF will once again have inward direction. So if I am assuming inward to be positive, this will be negative, this will be positive, or vice versa. You can assume negative, positive, negative also.
Sir, is it 5 mu naught I theta by 24 pi?
Now you are right. Now you are right. Are you getting? I think last time we not did convention of sign.
I took everything as possible.
Yeah, you took everything as possible. But it is not true, right? Because directions are different. If one thing is acting like this, one is acting like this, they will cancel each other, no? It will be changing, yes. So now, what is the magnetic field due to the part AB? It will be, by the same logic, it will be mu naught I by 4 pi, instead of R it will become 3L, because this AB part is L, 3L away. Mu naught I by 4 pi R into theta. What is theta? Let it be theta itself, nothing mentioned also, theta. What will be magnetic field due to CD? Mu naught I 4 pi into 2L into theta. But see, AB will be positive, this will be negative. Don't you agree? Because AB, CD I have taken it as negative into out of the plane. What will be due to the EF? Mu naught I by 4 pi L into theta. Once again positive. Now what is the net magnetic field at that point? Add all these three. So mu naught I by 12 pi L into theta minus mu naught I by 8 pi L. 4 pi I could have taken common, it will be more easy for me. Why to take 12 and all these things? 4 pi into 3L, let me write like this itself. Here 4 pi into 2L plus mu naught I by 4 pi into L. Here also theta will be there. So if I take common terms will be what? Mu naught I theta by 4 pi L 1 by 3 minus 1 by 2 plus 1, right? How much you will get? 6 as the LCM you will get, and you will get above as 5. So B will become 5 mu naught I theta by 24 pi L. Same thing you got, right? 5 by 24 into mu naught I theta by pi L. This is the answer. Got it how it came? Interesting question. Because direction of magnetic field is changing. For this part, it is into the plane. For this part, it is out of the plane. Once again, this part into the plane. If you are understanding, copy this fast. I will give the next question then. Be ready for the next question. Once again, a board question I am giving. Can I proceed? Shall I get the next question? If you permit me, I will go to the next page.
How did the 3L became? Nothing, sir. Nothing. Sorry, sir.
If you are done, I will go to the next page. Shall I? Oh. Yes, Vineshwaran, tell me. How I took that? Very good. So, shall I take it as something else? I can take mine if you want. I will take it as X. That is not a problem. This is magnetic field, and this is just denotation by AB. Good question. You are teasing me, or I don't know. Okay, next question I will take. This question has come in the board examination. They have told there are two circular conductors which are having common centers, okay, and carrying same current I. current I, here also current I, and they have a common center. What is the magnetic field at this center? Question is clear? Same radius, both have same radius R and R. There is also radius R, here also radius R. I hope question is clear. One circle is like this, one is like this, and they are asking in center what is the magnetic field. Both are carrying same current I, both are having same radius R. They are asking you to find what is the magnetic field at the center. What is the answer? Mu naught I by? No way. Magnetic field is a vector quantity. Think and solve. Mu naught I by, let me check it. Tell me again what you said. Sounds little correct. Let us check. So, first of all, direction I said very important, vector quantity. This is the direction of magnetic field, right, in the vertical coil. So, magnetic field will be somewhere acting like this. Do you agree with me? Right? Because it is like this, magnetic field in this direction. Same with this one is taking the current in this direction. So, magnetic field will be acting in this direction. Do you agree? I am writing B for both. Why I am writing B for both? Because both have same current, same radius, isn't it? So, the net magnetic field will be in this direction, root over B square plus B square plus 2B square cos 90. Do you agree with me? Vectors A square plus B square plus 2AB cos theta. So, it will become root over, this will become cos 90 is how much? 0. This term will become 0. So, B square will become 2B square. So, it will become root 2 times of B. What will be that? Root 2 into mu naught I by 2R. So, the answer is as Niranjan told, mu naught I by root 2R. This is the value of net magnetic field at the center. This is also a board question. I hope it is clear to you. Good, Niranjan. Niranjan, have you learned this chapter in the school? No, good. Shall I go to the next question? See, these whatever I have solved now, both the questions are board questions, remember that. I am giving the next question to you. One more famous question is like this. On an axis, there are two loops. One is like this, another like this. Okay. This is having a radius of r. This is having a radius of 2 times of r. And then they may ask you, what is the magnet? Anywhere they may ask you. Magnetic field at this point they may ask you, or magnetic field at this point they may ask you, or magnetic field at the center they may ask you. Anywhere they may ask you. Let me ask you that they both are carrying current in the same direction, which is clockwise, and same amount of current, and I am asking you to find, suppose this point is x, this point is y, you want to find what is the B at y. Tell me. I hope you are trying to solve at least. Remember that both the coils are carrying current in the same direction. Direction of magnetic field is very important here. Here also magnetic field will be in this direction, and for this also magnetic field will be in the same direction. So the B1 and the B2 will be added. Are you getting my point? Since the current is like this, see, always remember our right hand rule is applicable to everything. If 4 fingers are giving current, thumb will give direction of magnetic field. If thumb is giving current, 4 fingers will give direction of magnetic field. So here current is like this, clockwise, right? So thumb is pointing in this direction. For this also current is like this, thumb is pointing in this the same direction. If I would have told current in opposite direction, they will be subtracted, because B1 will come here, B2 will come there. But now they are in same direction, they will be added. But what will be the value of B1? I am talking about, this is coil number 1 and this is coil number 2. So B1 is magnetic field at Y due to the coil 1. What will be that? I don't know, randomly I gave question. Let me solve it. That will be wrong, I think. I'll tell you why. So at this point Y, this coil 1 will produce a magnetic field. This will become axial point question. Magnetic field due to a circular current carrying conductor at an axial point. And I not gave you the value of this length. It must be given. Let me give it as 2r. Now you can solve. So what will happen? For By, the answer is By will become equal to B1 plus B2. And what will be the value of B1? Mu naught I r square by 2 into r square plus 2r the whole square power 3 by 2, right? Plus, what is the magnetic field at Y due to the second coil? Mu naught I by 2r. 2r means 2 into 2r will become 4r. Solve this, will get the answer. That's all. I hope you are understanding something. So for one loop, it is magnetic field due to circular carrying conductor at the central point. For one loop, it is magnetic field due to circular carrying conductor at an axial point. I hope you are understanding. Answer is secondary, you can solve it later also, but the concept is clear to you. Even if you felt the topics that I taught today was complicated, don't worry much about it. In the next class it will become fine, but practice, don't leave it. Today itself, after going to home, what book you have, that is that book we gave for the board examination. From that, this topic, whatever I have taught till now, Biot Savart Law applications, I think there will be some 20-25 questions that will be there up to what I have taught. Solve those questions. When you solve those questions, you will get an idea about how the questions are coming in the board examination. And ask doubts if you have anything to me. Is it clear to you? So, today's class was based upon the 4th chapter. Maybe some complications may be there because it's a new chapter, but don't worry, it is very simple. We learn only 3 things, actually 4 things. One is Biot-Savart law, which is mu naught by 4 pi I dl sin theta by r square. Then we learned about magnetic field due to a straight current carrying conductor. Mother formula is mu naught by 4 pi r into sin theta 1 plus sin theta 2. For a normal straight wire, that is very long straight wire, the value becomes mu naught I by 2 pi r. For a circular current carrying conductor, magnetic field at center will be mu naught I by 2 r. For circular current carrying conductor at an axial point, the magnetic field is mu naught I a square by 2 into a square plus r square power 3 by 2. And based upon all these things only, today we solved questions also. Okay? I am repeating, whatever we learn today is simple. If you go home and practice some questions based upon this, otherwise it will become very tough. Again I am repeating, all these questions, directions are very important. That's why you are not able to solve. This thing is vectors, this thing is also vector. One kind of question is there, how it came in the board examination. One coil here, one coil here. What is the magnetic field at this point? So current in this direction, current in this direction. Simple only it is, very simple question only. So this will have magnetic field in this direction. I am writing it as B1. This will have in the downward direction, B2. Answer is somewhere here. B1 square plus B2 square plus 2B1 B2 cos theta. But B1 will be by axial point formula, which is mu naught I a square by 2 into a square plus r square power 3 by 2. B2 will also be found by axial point formula. That you should be very careful, because this point is what point? Axial point for this circle also, axial point for this circle also. Are you understanding it? If not also, go home. Whatever I am teaching now will be there in the recording. See it once again if you are confusing. And please solve some questions based upon it. We are into the 4th chapter, the last difficult chapter of physics. And it is not difficult for everybody, believe me, if you are understanding it. So, please go home and practice, and we will meet again in the next class. Kirti, you had some doubts that you have asked to me. Shall I arrange a class for you on this Friday separately? Because separately if I do, it will be easy for me to teach you. I am tired also too much now. Okay. So we will meet on Friday for a class. Remind me, I will send you a link for that separately. Take care, bye-bye. Take care, bye-bye. Camera, please be very careful about the camera. Be very careful about the camera.